And when I hit the ground, I just remember realizing I forgot where I was. Like everything was just gone from my head. And as we walk out of the ring, we had an athletic trainer who was on the road with us, and he stopped me because he could tell something was wrong, but I just blew him off and just suffered through because I just assumed the headache would go away soon and I'd be fine, but it didn't.
That's behavioral neuroscientist Chris Nowinski, co-founder and CEO of the Concussion Legacy Foundation. In 2002, he debuted on Monday Night Raw, a popular pro wrestling show produced by the WWE. It was only a year later that Chris found himself in the ring, totally unaware of his surroundings. And in the days following the match, he continued to struggle.
I couldn't exercise without feeling nauseous. My head was throbbing all the time. My memory was terrible. I could barely hold a conversation. And I remember before one of my final matches telling the group I was wrestling with, nothing is sticking in my brain. So if I blank out there, just tell me what to do. I knew it was conscious enough that my brain wasn't working, but I didn't know what that meant. And the reason I stopped wrestling was not because I got smart. It was because the night after my last match, I developed what's called REM behavior disorder. I was found standing on the bed, couldn't be woken up, and I jumped through a nightstand, hit the ground, didn't wake up. And when I finally did wake up, I had no recollection of this sort of horror scene and wrecking the room. And that's what it took to make me realize I was scared to go back to sleep. And I started being honest about what was wrong with me. And at that point, I had done so much damage of a concussion upon so many hits to the head that was it.
Chris didn't know it at the time, but this would be a pivotal moment, not just in his life, but for an entire field of research on a neurodegenerative disease long known to exist, but poorly defined and even censored: chronic traumatic encephalopathy, or CTE. Welcome to Tiny Matters. I'm Sam Jones, and today I'm joined by my guest co-host, science communicator and video producer Alex Danis.
Hey, Sam. I'm glad to be here and so glad to be taking on a topic as important as CTE. Today on the show, we're going to cover what's known about this devastating disease and how to prevent it, and how researchers are trying to find ways of diagnosing it in people who are still alive in the hope of one day finding treatments. A disclaimer that there will be many discussions of self-harm in this episode, so if it's not for you, go check out our back catalog. We'll return to Chris and his story soon, but first, let's travel back to the 1920s. On October 13th, 1928, Dr. Harrison S. Martland published a paper in the Journal of the American Medical Association simply titled Punch Drunk. He wrote, "For some time, fight fans and promoters have recognized a peculiar condition occurring among prize fighters, which, in ring parlance, they speak of as punch drunk." He goes on to say that fighters have symptoms sometimes recognized as, quote, goofy or cuckoo by fans. Later on, he writes, in severe cases, mental deterioration may set in, necessitating commitment to an asylum. In the article's conclusion, he states, the condition can no longer be ignored by the medical profession or the public.
But for many decades, it was. It wasn't until the early 2000s when American football players began being diagnosed with CTE post-mortem, often after they'd taken their own lives, that the disease gained public traction. So what is CTE? It's a degenerative brain disease caused by repeated traumatic brain injuries. A traumatic brain injury, or TBI, is really an umbrella term. A concussion is a form of TBI, but a non-concussive hit to the head, meaning the person doesn't report symptoms like headache, nausea, or double vision, can in fact sometimes be harder than one causing those symptoms. These non-concussive hits can also cause traumatic brain injuries. CTE has a range of symptoms, and they overlap with a number of other conditions. But some of the most common symptoms are problems with cognition, including executive function and memory, neurobehavioral dysregulation, motor symptoms similar to what's seen in Parkinson's disease, problems with sleep, and progressive dementia.
A hard hit to the head can cause damage to your neurons. Neurons have long fibers called axons projecting off of them that transmit electrical impulses from one neuron to the next. And when they stretch, like in the case of a TBI, they can become injured or tear completely. Axons are, in part, made up of microtubules assembled and stabilized by tau proteins in your brain. That's TAU. But when an axon is damaged during a TBI, the tau proteins can misfold and malfunction, causing surrounding tau proteins to do the same. With this axon damage and tau buildup, the neuron can no longer send signals and dies.
And as neurons in different regions of the brain begin to die off, you start to see symptoms. With CTE, researchers have discovered a buildup of tau, particularly in the front of the brain, in regions associated with impulse control. In more advanced cases, there is also buildup of tau in the more central memory centers of the brain, like the hippocampus. Alex, considering what we know now, I can't stop thinking back to how little was known about this when we were growing up. Like, we knew that concussions were bad for your brain, but other repetitive head impacts that didn't cause symptoms were just part of playing sports. I mean, how many headers did I go for on the soccer field as a kid?
I know. I did over a decade of Taekwondo. I don't want to think about how many times I was punched or kicked in the head, though thankfully, I was always wearing protective headgear.
When I was growing up, no, I don't think I heard much about concussions. I was a three-sport athlete my whole life. And I do remember very vividly, I had friends in 7th grade who were playing tackle football for the Arlington Cowboys. And I asked my mom to play, and she said no. She was worried about orthopedic injuries, and who knows what intuition she had about the brain. But I wasn't allowed to play until high school. And in high school, I just kind of bullied her into letting me go show up for the first week of practice.
10 years earlier, the son of Chris's high school football team's defensive coordinator died of second impact syndrome. He had received a second head injury before completely recovering from one he had previously received. While it's rare, that can cause rapid swelling in the brain that's fatal within minutes. The player who died was named Kurt Thyreen.
Kurt got a concussion in a game but didn't tell anybody. And it was so bad that he couldn't play he was like a brass player in the band. Couldn't play it because his head hurt too much. But nobody ever put those things together, and he went and played the next Friday night and got another hit to that and died. I had an opportunity to learn about concussions, their seriousness, but it never processed for me. So I do remember in college, like when other people would get concussions after missed practice, I thought they were soft.
Chris went on to play football at Harvard and then, much to his own surprise, ended up in the WWE shortly after graduation.
I actually didn't grow up watching pro wrestling. The summer before my senior year of college, 6 of us stayed on campus to train, for the season and, potentially being NFL prospects. So 6 of us to a 2-bedroom, 1-bath apartment. It was quite disgusting. But I remembered very vividly that the guys were wrestling fans, and every Monday, Thursday night, we watched wrestling together. And at that point, it was sort of like peak of wrestling where The Rock was, coming into his own, and Stone Cold was at his peak, and it was just great television. And so I became a big fan very quickly. The summer I learned about wrestling, I was also interning at this company doing life sciences consulting. And just over a lunch conversation one time, the boss said, well, if you don't get drafted by the NFL, have you ever considered becoming a pro wrestler? Because we would talk about pro wrestling, and he knew people in pro wrestling for some reason. And he just had this intuition that I could be good at it. And so when I ended up not getting drafted, he made some phone calls. I hadn't even graduated yet. And suddenly I'm being flown to Atlanta for a tryout with Mr. Wonderful Paul Orndorff for WCW.
Paul Orndorff, nicknamed Mr. Wonderful, was a pro wrestler and football player, a huge star in the 1980s and 90s who ran a professional wrestling school called the WCW Power Plant. Soon after Chris began training, the WWE announced a reality TV show with MTV called Tough Enough, and Chris was selected. He moved to Stamford, Connecticut, and filmed 24/7 for 13 weeks straight, competing for a job with the WWE. He was runner-up, but it wasn't long before the WWE came knocking. Chris's first match was on Monday Night Raw in June 2002, in front of millions of viewers.
Fast forward to a year later, and Chris is wrestling in a tag team match at the Hartford Civic Center.
It was just a quiet night in the arena. Not that many people were there. And so I remember we decided to move a little faster with a little more energy to try to get the crowd more into it. And I just ended up sticking my face probably 3 inches closer to his foot than it should have been for a boot in the corner, something I'd done a million times. And it just took my head off. And when I hit the ground, I just remember realizing I forgot where I was. Like everything was just gone from my head. And that's a problem in a pro wrestling match because the one thing you agree on before you go out there is how you're going to finish the match, right? There has to be a sequence of events that makes sense, and somebody has to lay down for all 3 counts of the pin, and that was gone.
Chris remembers getting up and telling one of the wrestlers that he couldn't remember the rest of the match. Who was getting pinned and when was it happening? He knew something was wrong.
And at that point, we weren't trained to know what that was or to stop the match. Now I actually go in and provide those trainings for the WWE, but back then we didn't. And so it wasn't like the ref stepped in and said, our match is over. We just kept going and they just told me what to do and I was able to follow easy commands until we got out. But my head was throbbing and I couldn't remember what's going on. And as we walk out of the ring, we had an athletic trainer who was on the road with us and he stopped me because he could tell something was wrong, but I just blew him off and just suffered through this because I just assumed the headache would go away soon and I'd be fine. But it didn't.
Chris had a week off to recover, but he told us that because he was worried about keeping his spot in the WWE and also didn't grasp the severity of his injury, after that week he lied and said he was fine. Soon he was back on the road, continuing to wrestle and continuing to get hit in the head.
And during this whole time, I couldn't exercise without feeling nauseous. My head was throbbing all the time. My memory was terrible. I could barely hold a conversation. And I remember before one of my final matches telling the group I was wrestling with, nothing is sticking in my brain. So if I blank out there, just tell me what to do. Like I knew it was conscious enough that my brain wasn't working, but I didn't know what that meant. And the reason I stopped wrestling was not because I got smart. It was because the night after my last match, I developed what's called REM behavior disorder.
Someone with rapid eye movement or REM sleep behavior disorder will physically act out dreams, sometimes violently kicking or thrashing.
I was found standing on the bed, couldn't be woken up, and I jumped through a nightstand, hit the ground, didn't wake up. And when I finally did wake up, I had no recollection of this sort of horror scene and wrecking the room. And that's what it took to make me realize I was scared to go back to sleep. And I started being honest about what was wrong with me. And at that point, I had done so much damage of a concussion upon so many hits to the head that was it.
Chris began searching for a doctor to try to understand what was happening to him. That's where neurosurgeon Robert Cantu came in and upended everything that Chris thought he knew about brain injuries.
He changed everything I knew about it with a simple question. At that point, I'm now 24. He asked me, all right, so you've had the symptoms for a couple months. How many concussions do you have before this one, if this one was a concussion? And I was like, well, I don't think I've ever had a concussion. I've never been diagnosed with a concussion. I think I'm fine. And he goes, okay, well, how many times were you hit in the head and you saw stars, or you were dizzy, or you confused, or you forgot where you were, the sky would change colors, you had ringing in your ears, and he went down the full list. And I remember breaking the smile going, geez, that's all the time. Like a ding, a bell ringer. Like I told him that's happened a bunch. And he goes, all right, can you remember those instances? And it was easy for me to remember 6 just in my wrestling career, let alone football before that, soccer before that. And he goes, okay, so maybe you've had some other concussions that you called dings or bell ringers, but you never took time off for.
He told Chris that his brain really needed rest after every one of those instances. Not resting made things a lot worse.
And so I was just blown away with this idea that I didn't know what a concussion was as a Harvard grad in my 20s. I didn't know you needed the rest, which I would have happily done if I knew it would take away this pain. And then the third thing was, he goes, and we don't really know what this means long term. I can't say what you're going to get better. I can't say what this is going to lead to. It's really an important area of research. And I was like, geez, I might have screwed myself up for life. And that was just like this moment of just like, what the hell was I doing here? And why didn't I know any of this stuff? Well, I've been aggressively banging my head for the last 18, 19 years.
Following his meeting with Robert Cantu, Chris became laser-focused on learning more. He started buying day passes to the Harvard Medical School library, photocopying all of the concussion studies he could find, and began reaching out to former football teammates who had retired due to concussions.
At that point in my mind, it was, if you retire from concussions, or the doctors make you retire, you're getting out before things got bad. And when I talked to them, they told me, no, I still have symptoms every day. I just don't tell anybody because what's the point? And I realized, oh, I'm not the only one who's gone through this.
Soon, Chris had the idea for a book which would become Head Games, Football's Concussion Crisis. It was released in October of 2006.
The reason I wrote Head Games, Football's Concussion Crisis was twofold. First, it was to ensure that other people didn't go through what I went through. I could not believe that I didn't understand what concussions were, but the more I talked to athletes, the more I realized none of us did. And so there needed to be something out there that would explain to people the seriousness of this issue and how people could protect themselves. Second reason I did the book was because the more I dug into it, the more angry I got about the role that the NFL had been playing up to that point in minimizing the injury. And I felt like there was a bit of a big tobacco cover-up going on. And so I wanted to put that on paper so that people would start to look into this, because they would control sort of the future in sports of this concussion culture by what they did on the field. I didn't realize, I think at the time, what those accusations meant or where they could go. But I do remember now that, part of the reason not many people read the book is because it wasn't a commercial book. I got a $4,000 advance to do it. But for the things I accused the NFL of, I had to pay $21,000 in libel insurance in the first 2 years. And so it was an interesting project.
Yeah, to say the least. So a big part of the reason that you wrote it was to protect people so that they wouldn't go through what you went through. So like protect people in a sense that they have a better understanding of what a concussion is. And if you have that, you should not just like get back on the field, get back in the ring. Are there other things that you felt like, okay, this is like actionable advice that I'm providing based on the very little that we know at this point?
Yeah, one of the big things was informed consent, right? If you're going to destroy your brain or destroy your brain health, you should know what you're doing it and know that you got a choice. The other part that sort of becomes opened up when you open up that can of worms is like, when do kids have informed consent, right? And the whole idea of we're lining kids up at 5 years old, buying them helmets and asking them to take each other out. You do that enough, and you're going to get concussions and you might get CTE. That conversation wasn't happening in this country. That bothered me, that we were putting kids through this, because the book process started interviewing, high school students whose lives were derailed, and, the trajectory their life was on was now different. I remember one kid who couldn't recognize his parents for 3 months after concussion. It was just insanity.
Another important point the book brings up is that getting hard hits in practice is not needed to teach you to play football. No one should be getting a concussion or other traumatic brain injury while practicing.
I was hit less, understand what concussions are, try to convince athletes to tell you when they happen, and then take time off. Right? So back then, the NFL used to brag that 50% of the guys who were knocked unconscious in a game returned to the same game and survived. That was a conclusion of one of their studies, and therefore concussions are not a big deal. That was crazy. So the idea now that it's state law that you can't go back into the game when you have a concussion is exciting.
By 2014, all 50 states and Washington, D.C. passed return-to-play legislation that, in most places, requires that athletes immediately stop playing if a concussion is suspected and can only return to practice or competition after a healthcare provider has cleared them after a minimum of 24 hours. In the NFL, players now aren't allowed to return to the game if they're concussed until they have passed a 5-step evaluation and been cleared by 2 medical professionals. So there have been some changes over the last couple of decades. In addition to concussion response, the NFL has made some changes in their rules regarding hits and now allows players to wear guardian caps, which are cushioned sleeves that go over helmets and seem to help some in reducing impact. But back in October of 2006, when Head Games came out, the risk of CTE was far from public knowledge. Then, on November 20th, 44-year-old former NFL defensive back Andre Waters died by suicide.
He was known for being a hard hitter. His nickname, I remember reading an article after he retired, was Dirty Waters, because he liked leading with his head. And so when I heard he died by suicide in his mid-40s, I started searching for any references of him in concussions to see if he had any. And I found a quote from an old article saying he stopped counting concussions at 15. He would just sniff smelling salts and get back out there. And so that was sort of this moment where I was like, oh gosh, if anyone's going to get CT, based on what we thought we understood about the behavior back then, it was him. And so I ended up having to, call the medical examiner, and he had kept part of his brain after he was buried per Florida state law in a death of unknown cause, and then called the home of his 88-year-old mother. Andre's sister picked up, and I had to convince them that, hey, I know you think Andre's buried, but his brain is still above ground, and can we study it? But luckily, they were amazing.
Andre Waters' brain showed severe deterioration and an accumulation of tau proteins in patterns specific to CTE. Waters was in fact the third NFL player diagnosed with the disease. The first was former NFL player Mike Webster, who in 2002 died of a heart attack at the age of 50, but leading up to his death had shown changes in his behavior and memory loss. The second NFL player diagnosed with CTE was Terry Long, who in 2005 died after drinking a gallon of antifreeze. Chris doesn't remember any mention of CTE in a national news story before Andre Waters. His death was a turning point.
So when Andre Waters took his life, I worked with the medical examiner's family to get his brain studied, and then took those results to the New York Times, courtesy of Alan Schwartz, became a famous reporter for them through doing this work. And I remember sitting in front of the editorial board saying, hey, look, there's this huge public health problem out there. The NFL's covering it up, and you need to tell Andre's story. And Jason Stallman, who was then assistant sports editor, saying, we're the New York Times, how do we not know this? And I said, well, they're doing a really good job covering it up.
On January 18, 2007, Alan Schwartz of the New York Times published a story titled Expert Ties Ex-Player's Suicide to Brain Damage.
People, when they read that story, had the same shock I had, was how can this be happening? How can we not be talking about it, especially in a sport where we have millions of children playing this every year? So the idea was I've got to do what I did with Andre Waters over and over and over again to convince the world this is real. I was probably a little naive and hoped that when the Andre Waters story broke, the NFL would be like, oh, maybe we have this wrong. Maybe we should take this more seriously. Of course, that didn't happen. They dug their heels in further. So I said, fine, let's see how long you can dig your heels in.
Chris continued reaching out to the families of former NFL players and other athletes who had recently passed away to arrange brain donations.
When I heard about someone dying, I would cold call the family. And I had ways to track that information, sometimes through friends, sometimes through public listings. And then I would have to convince them very quickly that I'm worth talking to on usually the day after the worst day of their lives. But luckily, these families had seen their loved ones suffer, and I understood the stakes.
In June 2007, Chris and Robert Cantu founded the Concussion Legacy Foundation, a charity organization created to support people affected by concussions and CTE, to promote smarter sports and safer athletes, and to end CTE through prevention and research. In 2007, Chris also coordinated the evaluation of the brain of 40-year-old WWE wrestler Chris Benoit. Benoit hanged himself after murdering his wife Nancy and their 7-year-old son Daniel. I remember this so distinctly. I wasn't even a wrestling fan, but I just remember being so shocked and so confused, and I can only imagine that the wrestling community was like to the nth degree of that. So results did show that Benoit had CTE when he died. And this brought awareness to the fact that it was not just boxers or football players who were developing CTE. It ran a lot deeper than that.
In 2008, the Concussion Legacy Foundation partnered with Boston University and the U.S. Department of Veteran Affairs to found the Unite Brain Bank at the Boston University CTE Center, the first academic center to study CTE and the world's first athlete brain bank. At the same time, Chris was completing his PhD in behavioral neuroscience. Today, the Unite Brain Bank has 1,600 brains that have been donated, and the Concussion Legacy Foundation has a registry of 12,000 people who've signed up to donate their brains when they die. Many also take part in research studies. Chris told us that about 80% of the brains come from families calling the brain bank, and another 10% are medical examiners calling, but there are still cases of public interest where Chris will try and track down families and ask for a donation. These stories of Chris Benoit, Andre Waters, Mike Webster, and Terry Long are unbelievably sad. But even sadder, their deaths are just the tip of the iceberg. In 2023, the Boston University CTE Center announced that of 376 former NFL players studied, 345 had CTE when they died. That's nearly 92%. As a comparison, a study done in 2018, also by Boston University, showed that only 1 of 164 brains donated by men and women from the general population showed CTE. That's 0.6%. And that one person was a former college football player.
Some of these players have also been incredibly young. Take the case of Aaron Hernandez, a former New England Patriots player convicted of murder in 2015. In 2017, at just 27 years old, he hanged himself in his jail cell. Hernandez's family donated his brain to the Unite Brain Bank, and they learned that he had severe CTE. Neuropathologist Anne McKee at BU's CTE Center reported that this was the most severe damage she had seen in a brain younger than 46 years old. In 2023, the BU CTE Center diagnosed CTE in the first American woman athlete, an unnamed 28-year-old female soccer player. And there are even younger players being diagnosed with CTE. In July 2019, just after his high school graduation, 18-year-old football player Wyatt Bramwell died, and he was the first teenager to be found to have stage 2 CTE, meaning it had already been spreading in his brain for years. In 2023, researchers at BU's CTE Center looked at the brains of 152 amateur athletes who played football, soccer, ice hockey, rugby, or wrestled, and died before age 30. 41% of them showed evidence of CTE. Hearing these stories might make things feel a bit hopeless, but they're not. Of course, Chris mentioned a couple of changes that help in preventing CTE, including adequate recovery after head trauma and eliminating hits during practice, as well as minimal changes within the NFL. But there's also a lot of research going on across the globe, and the BU CTE Center is leading the charge.
The main goal of the CT Center is to better understand the long-term effects of repetitive head impacts from all types of sources on the brain, with a focus on chronic traumatic encephalopathy, CTE, and to better characterize what CTE looks like neuropathologically, what are the mechanisms that drive the relationship to CTE, and then ultimately, how can we detect, diagnose, and then treat CTE during life to help people.
That's Michael Alasko, a clinical researcher and neuropsychologist at the BU CTE Center, overseeing clinical research on the disease.
From the 1920s and really up until 2005-ish, there's been these kind of symptoms been described in boxers or fighters, and some pathological studies where they find kind of a unique or irregular pattern of tau. But then it was really the work of Dr. McKee at Boston University where she characterized what this disease looks like under a microscope. And she, along with a large consensus panel of other pathologists across the world, published initial criteria for diagnosing this disease in 2016. And so that's in 2016 when we had the actual published criteria for how to diagnose this under a microscope.
Research has also shown that there isn't an obvious connection between the number of concussions someone has gotten and CTE, but instead the number and strength of repetitive head impacts overall.
We have failed to find associations between number of concussions and risk for CTE pathology in our brain bank, but rather it seems to be just kind of this overall cumulative lifetime exposure of head impacts at high intensity that is the main driver of this disease.
There are still additional factors that researchers are trying to tease apart, like the impact of genetics and environment on risk of developing CTE, because not everyone who plays years of a high-impact sport develops the disease. Michael's interests lie in finding ways to detect CTE while a person is still alive.
In 2021, through kind of an NIH-convened consensus, we did come up with research diagnostic criteria for the syndrome of CTE pathology. It's known as TES, traumatic encephalopathy syndrome. And I just bring this up because those criteria and now research since has kind of been getting us closer to understanding the specific signs and symptoms of CTE. Our data show a really strong link between the CTE neuropathology and cognitive symptoms. But where we are struggling a little bit is these mood and behavior symptoms that you hear about more frequently in the news and the media. We're trying to figure out what those causes are.
Michael is also looking for biomarkers of CTE that, when combined with symptoms, provide a more accurate diagnosis of CTE while someone is alive. We often hear about molecular biomarkers, like excess glucose in the blood being a sign of diabetes, or physiological biomarkers, like high blood pressure indicating hypertension. But Michael is interested in imaging biomarkers. He and his colleagues are using PET, or positron emission tomography scans, which create 3D images inside the brain. With PET scans, a radioactive compound called a tracer is injected into your bloodstream, where it then travels to your brain and sticks to a protein of interest. In this case, tau. Remember, misfolded tau proteins build up in damaged neurons. Tau tracers already work well for Alzheimer's disease, but the misfolding of tau in CTE is different from how it's misfolded in Alzheimer's. So the research team is still working on a good tracer for that specific tau to detect CTE. Michael and his colleagues are also working with structural MRI, which uses magnetic fields to create images of the brain's anatomical structures.
So as part of any memory workup, a structural MRI is routine. What you're looking for is there shrinkage or atrophy, neurodegeneration in the brain? And what are those patterns? And the patterns can point you to a potential cause. Alzheimer's disease has a specific pattern. The memory centers are involved. In CTE, we've conducted studies where we've identified some unique features and patterns on MRI in people with known CTE because they had autopsy. But then if you also look across the literature on studies looking at people at risk for CTE, it does tend to converge on more shrinkage in the frontal lobes, the temporal lobes. We see more likelihood of having what we call a cavum septum pellucidum, or kind of a tear in the tissue that separates the ventricles. And we see atrophy of the hippocampus as well. We get a lot of people concerned for CTE, and we're not at the place where we can accurately tell someone if they have changes consistent with CTE in the brain. We're not quite there yet.
It is anxiety inducing sometimes when you think about this work all the time and what could happen to me. On the other hand, when you read obituaries every day, you also realize we're all going to die of something. So I am able to detach and go, as long as I'm not symptomatic and it's not impacting my life right now in any significant way. I mean, I certainly am not who I was, but I'm still okay. And so I don't worry about that. I do try to, live every day the best I can and appreciate the time we have. But also, like, all that anxiety that I do feel, I sort of just bury into my work ethic. I guess there's a reason why I'm doing, working every day and, taking calls on the weekends and nights and trying to move this forward, is because I'm either trying to save myself or I'm saving a ton of the people that I built great friendships through sports with. And so it's not hard to stay motivated to keep pressing forward.
Your experience, your work as a neuroscientist, working with these families, former teammates, friends, how has that impacted your view of football, of these high impact sports where people are getting concussed all the time and they're at a very high risk of developing CTE?
I gotta admit, my opinion on this sort of changes and evolves, with our work and with the conversations I have, because it's not an easy, simple answer. Recently, one of those guys that I lived with in that house for summer when I watched wrestling, summer '99, I shared a room with, was Chris Eitzman, and we just diagnosed him with CTE after he drank himself to death. And so someone I knew for 25 years, this thing is ugly. Like, there's no way to slice it. Sports are wonderful, and I still play sports on a regular basis, but I don't play anything that's going to get hit in the head, because your brain is a very special and fragile thing, and it can just take one bad hit. It could be a fall, but it could also be a collision with somebody in a sport that can change the trajectory of your life. And so now that I have 2 kids, like, I can promise you, after the horrors I've seen, that they're never going to play a sport where they're getting hit in the head on a regular basis. I often tell my friends who want their kids to play football, but that's great. If you think your son, that exposure will help them in life, that's great. But what we don't talk about is that there's diminishing returns to football. Your son will figure out how to be tougher within weeks on a football team, and maybe a season or 2. But after that point, they're not going to be learning a whole lot more lessons about toughness and grit and resilience. But what they are going to be doing is adding miles to their brain. And if they play 10 years of this sport, you should not be surprised if they're found to have CT someday. Soccer doesn't admit that their game causes CT, and so we're still heading balls willy-nilly. And that's a shame. And so hopefully we can sort of have this more objective, rational, scientific discussion about, not everyone should play, and that's a choice by parents. But then if you're going to play, how do we play smarter so that you don't walk away with the brain disease that will change the course of your life? And some people do okay with the brain disease, but we know a lot of stories of people who it wrecks their entire family. And that's not what sports should be doing.
Absolutely. Do you have that conversation with your kids? How old are your kids?
So my kids are 6 and about to turn 4. They know daddy's a brain scientist, and they know they're not supposed to hit their head. My son, since he was 2, would say, I can't do that. I might hit my head. He gets it.
You've trained them well.
Yes.
It's time to tiny show and tell.
I'm excited. So I went first last time that we did this. So do
Yes.
you want to go first this time?
Yes. I'm actually going to start my tiny show and tell today with a question for you.
Ooh, okay.
Okay, when is the last time you cleaned your microwave?
Oh, dear. A while ago? Let's say a while ago.
You know, if there's food that's splashed, I immediately clean it. But
Yes.
otherwise, I think I just let it exist.
Yeah. Yep. Same.
And I think that's pretty standard. But researchers have just reported in the journal Frontiers in Microbiology that our microwaves are teeming with bacteria.
Oh, no.
So what they did was they looked at 30 microwave ovens that were being used in 3 different settings. So they looked at 10 that were used in people's kitchens, 10 from labs, and 10 from other shared spaces like cafeterias.
Okay.
What they did was they swabbed them, took that swab, transferred it to lab dishes like Petri dishes to see what would grow. And all of them had significant bacterial growth. And I just want to note before I talk about bacteria, this is the first time that scientists have actually documented microbial communities in microwaves, which feels like someone should have looked at this before. I don't know.
It does, but also for me, I think the part that's most shocking to me is that something can live in my microwave, that it is being quote unquote cooked all the time. So I guess in my mind, why would you look there? Because it must just be a clean environment, right?
Yep, I think that that's logic that most people, including myself, would use as well. Let me just really quickly talk about this bacteria. So most of it was like no big deal. It's stuff that we often find like that just hangs out on the skin. It's not pathogenic, meaning it can't cause illness. But some of them were pathogenic. At least for the kitchen microwaves, the microbes found really similar to ones that you might find on kitchen surfaces that aren't clean. But we clean surfaces in a kitchen usually. Like how many times a week do I do like a full spray and wipe down of a counter that I would not do with a microwave? So what I thought was interesting is that the researchers say, you know, we don't really know how these bacterial strains survived in the microwave. How did they adapt to such high temperatures and electromagnetic radiation?
Yeah.
Which also I'm like, I have more concerns about that than the other bacteria. But they also stress like they don't think people should be overly concerned, but really they should start treating their microwaves like other parts of the kitchen that come into contact with food. So
well,
yeah, I'm going to clean my microwave after this recording, I think, is what I'm going to do.
Yeah, truly. That is now added to my list of things to do today because exactly, same as you. I wipe off a little sauce that splashes, but I just assumed nothing could live in there. But I'm so fascinated / terrified about microwave resistant bacteria. I didn't need to know that. I mean, I'm fascinated, but oof.
You know, maybe like once a week, I'll just kind of go in there, clean it out, and then leave it open to kind of like air out from any cleaner and
give it a good spritz.
Yeah, give it a little spritz.
So my tiny show and tell is on a very differently sized organism with a very differently sized genome. So there is a new winner of biggest animal genome on the planet, and it is a lungfish. So to give some scale and context here, human genome is about 3 billion base pairs long for one copy. The biggest genome on Earth, and I thought I knew the answer to this, but it turns out that it was unseeded a couple months ago. The biggest genome on Earth belongs to a plant that used to be the Paris japonica at 149 billion base pairs, but now is a tiny fern called there's a lot of letters that don't have vowels in between them here, the Temsipterus Oblanceolata, which is a tiny fern with 160 billion base pairs.
Okay.
But we have just done new sequencing of the South American lungfish and found that it has a 90 billion base pair long genome. So it is 30 times the length of the human genome. But interestingly, it has a very similar number of genes. So the human genome has about 20,000 sort of active protein coding genes, and so does this South American lungfish. So it has 30 times the amount of DNA, but the same number of genes. So there's a bunch of like intergenic non-protein coding stuff in there, which is kind of cool.
I wonder what some of it's doing.
Yeah. So a bunch of it they think is coming from transposons, which are these sort of quote unquote jumping sections of the genome that can copy and paste themselves to new places. And the lungfish don't seem to have a lot of control over these transposons. We and other organisms have some types of RNA that can sort of slow them down, keep them from expanding and expanding and expanding. But the lungfish don't seem to have this sort of control system as dialed up as we do. And so their genome grows super fast. So it said that over the past 100 million years, they've added the equivalent of one human genome to their genome every 10 million years. So they're just like
Oh my gosh.
growing and growing and growing and growing their genome, which I think is cool. And I think it's also neat that we found this new biggest animal genome. We have just recently unseated the biggest plant genome. And, a couple decades ago, sequencing a genome was like something that took you a decade and billions of dollars. And now we're just sequencing everything, which as a geneticist, I love because we're getting so much more information. We're learning so much more about all of these different organisms. But I kind of love that when I sort of went to write up my notes on this, I was wrong about the biggest plant genome because it had just been overturned. And now we have a new biggest animal genome. And we're going to keep finding new and different and bigger things, which I just think is fascinating.
That's really interesting. Thanks, Alex.
Thanks for tuning in to this week's episode of Tiny Matters, a production of the American Chemical Society. This week's script was written by Sam, who is also our executive producer, and was edited by me, Alex Danis, and by Michael David. It was fact-checked by Michelle Boucher. The Tiny Matters theme and episode sound design is by Michael Simonelli and the Charts and Leisure team.
Thanks so much to Chris Nowinski and Michael Olasko for joining us. We've added a bunch of great resources related to CTE to the episode description. A reminder that we have a newsletter where you can sign up for updates on new Tiny Matters episodes, find videos from interviews, and also some science stories that we just can't stop thinking about, and really just some other content that we think you might like. So I've put a link to that in this episode's description as well. We'll see you next time.